Kia ora and welcome to this first really quick video going through some of what we did in class. I'm pretty sure that these are exactly the 5 examples I covered on the board. If they're slightly different, I'm sorry about that. I'm just doing it from memory at home. This video will be pretty rough because I'm not trying to make it perfect. I just want to show you the working if there was anything you weren't clear on. Okay, so if we're simplifying this expression, I'll write it out again. So 3xy all squared multiplied by negative 2x all to the power of 3. The first thing I do is work with the first term and I get 9x squared y squared. Second term, I've got a negative 2 to the power of 3. Right, a negative number to an odd power will be negative 8 times x to the power of 3. Right, next step, multiply the numerical coefficients together. X squared times x cubed is x to the power of 5 times y squared. Okay, so writing that out again is negative 72 x to the 5 y squared. Right, next slide. Simplify the cube root of 27 x to the power of 27. So we can write this as a fractional power. So 27 x to the power of 27 all to the power of 1/3. So then, using our power rules again, we get this. So 27 to the power of 1/3 just means the cube root of 27, which is 3, times x to the power of 9. Next slide. Okay, this was where in class I explained that at this point all I'm really going to tell you about e is that it is just another number in maths, so it's 2.7 ... It's a really special, beautiful number, and we will spend some time talking about it later on in the year. But at this stage we're just doing algebra review, so I just want you to think about e as any other number. If we had this expression, 2 to the power of x times 2 to the power of x, then we would use the rule that the base is the same, so we just add the two powers. So 2x plus x, which of course is 2 to the power of 2x. So when we see e, we just think of it in the same way that we would think of a 2. The bases are the same, so it's e to the power of x plus x, which is e to the power of 2x. Okay, next question. Right, this one got quite a few of you remembering how we expand brackets. So, as I said in class, always best to write it out so that you don't miss out any middle terms. Okay, doing this quite slowly, I'm going to have 1 over x times 1 over x. So that will be 1 over x squared. Next, I'm going to multiply these two terms, and then these two terms. So as usual, I'll have 4 parts, and then lastly, our nice easy 3 times 3. Now I'm just going to add up like terms. So I get 1 over x squared plus 3 over x plus 3 over x is 6 over x plus 9. Okay, there's nothing more you can do with that. So next slide. Right, now this one is where I talked a little bit about the idea that sine of x is just a function. It's a trig function, and you're not used to thinking about trigonometry as a function. The reason these questions pop up in Delta really early is that we used to do more trig in level 2, so it used to be something you could put into revision. So you can think of this like this. Suppose that we had expand this x cubed plus 1 times x cubed minus 3. What we've got going on here is that x cubed is also a function of x, and so is sine of x. it doesn't matter. In both cases, we have x cubed times x cubed minus 3 plus 1 times x cubed minus 3. So that's just going back to how we do any expansion, right back when we started doing that in year 10. So we could expand this one, we'd get x to the power of 6 minus 3x cubed plus x cubed minus 3. Then we'd collect up our like terms. We get x to the power of 6 minus 3 plus 1, so minus 2x cubed plus 3. Now, those of you who are remembering from level 2 how we do that will know that typically we won't go through all of this palaver, but it is good to see it written out to jog our memories. So we'll just go x cubed times x cubed plus 1 times x cubed minus 3 times x cubed minus 3, and then we'll collect up the like terms again. Okay, I'm going to use a new slide to do the one with sign in it, but it's exactly the same principle. Alright, so the question is expand sine of x plus 1 times sine of x minus 3. Okay, so we're going to do the sine of x times the sine of x. Now the convention here is that it's fine to write it like the sine of x squared when we first start working it out, plus 1 times sine of x is just sine of x, minus 3 times sine of x minus 3, which equals, okay, so here comes the convention about how we write powers of trig functions, sine squared of x minus 2 sine of x minus 3. Now, don't let this freak you out too much. We will be looking at that a little bit more in 2 weeks' time when we start on trig. So this is our final answer for that one. Okay, have fun doing some delta tonight, and I hope this helps a little bit. Thanks for watching.